Define the Bronsted-Lowry concept. Recall that according to the Bronsted-Lowry theory, an acid is a proton, H to the power plus, donor, and a base is a proton, H to the power plus, acceptor. Analyze the forward reaction. Look at the reactants and determine which species is accepting a proton. NH3 becomes NH4 to the power plus. To do this, it must accept a proton, H to the power plus, from HCl. Therefore, NH3 is a Bronsted-Lowry base. Identify the acid and its conjugate. HCl becomes Cl to the power negative by donating a proton to NH3. This makes HCl the Bronsted-Lowry acid. The species that remains after an acid has donated its proton is called the conjugate base. In this reaction, Cl to the power negative is the conjugate base of HCl. Analyze the reverse reaction. Consider what would happen if the reaction proceeded in the opposite direction. To reform the reactants, Cl to the power negative would have to accept a proton from NH4 to the power plus to become HCl. Since Cl to the power negative acts as a proton acceptor in the reverse process, it is also classified as a Bronsted-Lowry base. Conclusion: the two species in this equilibrium system that act as proton acceptors, bases, are NH3 and Cl to the power negative, which corresponds to option B. The correct answer is option B, NH3 and Cl-.